All right, so let's explore these problems at the start. It's going to help you understand some of the things we're going to come across today in properties of real numbers. 34 plus 12, is that equal to 12 plus 34? We're trying to say either equals or not equals. Is this equal? And in fact, it is. Is 100 minus 1 the same as 1 minus 100? No, you can't actually switch them like that. Is 0 plus 180 equal to 180? Oh yeah, you can add 0 and it stays the same. Is 18 divided by 1/18 equal to 1? Actually, 18 divided by 18 would be 1, but not this. Is 45 minus 1 equal to 45? Nope, you can't take away 1 from it and it stays the same. And is 6 times 1/6 equal to 1? Yeah, if you take 6 and then you take a sixth of that 6, you're going to get 1. Okay, those are some properties of real numbers that we will illustrate in a bit. Check this out. Okay, relationships that are always true for real numbers are called properties. That's what we mean by properties. Always true for real numbers. Okay, they're rules that we can use to rewrite expressions or equations, and we have the equivalent value. Okay, we can compare expressions that way. Now, two algebraic expressions are equivalent if they have the same value for all values of the variables. Okay? Now, the following properties show expressions that are equivalent for all real numbers. Let me zoom this up a little bit. Okay. We have these rules for addition and multiplication called the commutative property, where we can change the order of the addends or the multiplicands, and we get the same number. A plus B is the same as B plus A. 18 plus 54 is the same as 54 plus 18. And A times B equals B times A. 12 times 1/2 equals 1/2 times 12, for example. That's commutative. When people commute, they move back and forth to work, right? Commuters. Well, these are moving back and forth in their position. Associative properties, also of addition and multiplication. These are the ones that it works for, okay? You can group these two first and add them, and then add C afterwards, or you can add these two first together and add A to the sum. Okay, just like 23 plus 9 is 32, plus 4 is 36, just like 9 plus 4 is 13, and 23 plus 13 is also 36. And it works for multiplication. You can multiply these two first, then take the product times this C, or you can multiply these two first and then multiply the product times A. For example, 7 times 9, 63, and then 63 times 10, 630. Or you could say 9 times 10 first is 90 times 7, again, 630. Okay? Associative. You're associating these two together in order to do them first. You're associating these two together to do them first. So commutative, commuters move back and forth. Associative, you associate or group things together to be done first. Okay, let's check out a couple more properties that we're going to be dealing with here. So we're first saying, let's just let A be any of the real numbers, any number in the real number system, because we're saying this applies to all real numbers, okay? The identity properties of addition and multiplication, they each have a rule that essentially allows the value to maintain its identity, okay? Check it out. If you add 0 to some number, you still get that same number, okay? 5 3/4 plus 0 equals 5 3/4. We saw that in the very first set of problems we were talking about, okay? Identity property, it maintains its identity as the same number. Or the multiplication identity property, where we multiply something by 1. A times 1 is just A, okay? It maintains its identity as that value. Yep, okay? The zero property of multiplication, on the other hand, says you can multiply any real number with 0 and you will get 0. A times 0 equals 0. 18 times 0, for example, equals 0. And the multiplication property of -1. The product of -1 and some number A is the negative of that number, negative A. Now remember, that number could start out being negative. So if you say -1 times -3, you're going to get the negative of -3, which is +3. Okay, but multiply it by -1, you're going to get its opposite, whatever it is, even if it started out as a negative number. Okay, so we're going to do some problems here. Okay, which property is illustrated by each statement. Before we look at those statements, I just want to point out here that parentheses and some operation symbols like addition, multiplication, and the numbers 0 and 1, they might be indicators that you were dealing with certain properties, like here's 0 in the addition property, the identity property of addition, right? Here's 1, here's 0, here's -1 in this case. So you can look for those for clues. First of all, what is the property? 42 times 0 equals 0. Well, that's right here, the 0 property. Multiplication, you multiply by 0, and you get 0. Okay, what about here? What are we doing here? Are we changing the order? No, we're not changing the order. This is where the parentheses from over here comes in. We're just grouping these two to be done first, or let's say starting out with this problem and saying, well, what it really makes sense is to do these two numbers that are like terms and group those together to be done. Okay, so we reassociate them with those two together. Associative property and its addition because it's addition. Okay. 10x plus 0, adding 0 maintains its identity, so it's an addition problem, and it's an identity situation because it stays the same, so it's the identity property of addition. Okay? Here is your got it problem. So one of the cool things you can do with these properties is that you can make mental calculations easier. Here's an example. If you are trying to find out the sum, total cost for a ticket, drink, and popcorn when you have these costs, use mental math. Well, here's how you can think of it, even though you're doing it mentally, right? You write these three numbers out, and what you really want to do is reorder them because this is 75 cents and this is 25 cents, and those 75 and 25 go nicely together to make a full dollar. So what we're going to do is we're going to first reorder them. That's the commutative property of addition. And then we're going to reassociate them. So you reordered these two right here. Now we're going to reassociate them. Instead of grouping those two and doing them first, we're going to group these two and do them first, the associative property of addition. When you do that, you get a nice whole number, 9. And then it's easy to add 9 with 2 and get 11 plus the 40 cents. Okay? And it says, how can you make the addition easier? Look for things that add together nicely, compatible numbers. Okay? So that's the cost. Now, your got it problem, and let me shrink it down a little bit so you can see it all. Okay. A can holds 3 tennis balls. A box holds 4 cans. A case holds 6 boxes. How many tennis balls are in 10 cases? Use mental math. You might want to write it out first and then try and apply one of our properties or one or more of our properties. So let's do a few problems with some of these properties. Simplify each expression. 5 times 3n. Well, let's see. What do we know? We have the expression. What do we need? We need to group the numbers so that they can be simplified. Okay? And we're going to use properties to group or reorder. Specifically, in this case, we're going to reassociate so that what we're doing is grouping here the 5 and the 3 because they get multiplied together, and we'll do that first, and we get 15n. Okay? What about here? 4 plus 7b in parentheses plus 8. What do we need to do? Sorry. We need to first reorder them. Okay? We reorder them inside the parentheses, so that's the commutative property. And now we're going to reassociate them. We're going to, instead of grouping these first two together, we're going to group the last two together because those are like terms. We can put them together like that. We get 7b plus 12. This one's an interesting one. What do we do here? This is 6xy over y. And check out what we're going to do here. Okay, look at closely. Okay, the identity property of multiplication. So what we say down here is, okay, y is just the same as 1 times y. That's what they're doing here, right? And now that they're using the rule for multiplying fractions where we can actually split this part off. This is the part that we kind of skimmed over. But here you have this times y over y, and if we split that off, you can see that 6x times y will be 6xy. You can see 1 times y will be y. That's what we had on the bottom. But this now is y over y, or y divided by itself, is equal to 1, and so we're just now taking this times 1, okay? And we get that identity property of multiplication. This whole piece canceled itself out essentially and was 1. Here's your got it problem. Okay, so without getting too technical, the method that we used for coming up with these properties is deductive reasoning, okay? The process of reasoning logically from given facts to a conclusion, okay? If you want to show a statement's not true, you just have to find a counterexample, something that makes it not true all the time. There's a situation where it's not true. You only need one. It's kind of awesome, okay? Now, let's look at this. If you can't find a counterexample, you can't think of one, see if one of the properties that you've got actually makes it true. Because just because you can't think of the counterexample doesn't mean there isn't one, but usually you can think of one. Often you can, okay? Let's take a look at this. Okay, is the statement true or false? If it is false, give a counterexample. For all real numbers, where you have two numbers here, a and b, a times b is the same as b plus a. Well, you can just take two numbers, a and b, 5 and 3. 5 times 3 is not equal to 3 plus 5. That's a counterexample, so you know that this is false. It's got to be true in all cases, okay? Now, for all real numbers a, b, and c, a plus b added and then c added to the sum is equal to b plus the sum of a and c. Okay, that's true. What are they using there? They're using the commutative property to change their order and the associative property to change the two that get grouped together and done first. Got it? Okay, here is your got it problem. Okay, do these lesson check problems and see how you understand this.